Welcome to day 1 of Daily Dose of Math. Today we'll be looking at what a metric space is. So metric space is basically a combination of the ordered set X, right? A set X and a metric definement. So assume any set X, right, which is non-empty. So a metric is defined as a function that maps from elements in X, between pairs of elements in X, to a number in real life. Okay, so when is any function that maps, which does this mapping from pairs of elements in X to real line, called a metric? It is called a metric when capital X, which is a non-empty set, when it satisfies following three properties. First property is what we call as non-negativity. Right? So which basically says that for all pairs of points x, y in capital X, it satisfies the property that d of x, y is always greater than 0, and d of x, y being equal to 0 is a by implication, or if and only if x and y are the same. So basically the metric, or the distance metric between 2 points in a particular two elements in a set is 0 if and only if they are the same elements. The second property which needs to be satisfied is what we call as symmetry, which basically says if you pick any two elements in a set x, y, the distance from x to y is same as the distance from y to x. The third property that needs to be satisfied is what we call as triangle inequality. So if you pick any 3 points x, y, z, or 3 points or 3 elements in the set, right, for all triplets of 3 elements in the set, what it's saying is if you take the distance between x, z, it has to be less than or equal to the sum of the metric value between x, y and y, z for you pick any 3 elements in X. So this is what we call as a triangle inequality. So if these 3 properties are satisfied by a function that maps from pairs of elements in X to a real line, we call that particular function as a metric, and the combination of the set and the metric defined on the set is what we call as a metric space. Okay, so that's it for now. Thank you.